This is AP Calculus 7-2, and in this section we are going to verify differential equations. So they will give us a specific differential equation and they'll ask us to verify that something is true. So in this one they say verify that if y equals e to the negative x, that is a solution to 3y prime plus 4y equals e to the negative x. So we're just trying to use this equation and then use what we get to plug into the new equation to verify that the left side equals the right side. It's pretty simple. It's kind of like doing a geometric proof, but this is more algebraic, but you're using calculus and derivatives to verify something. So over here we have a y, and we know what y equals, but we also have a y prime. So we're going to have to find the derivative of y to get that y prime, and y prime is equal to e to the negative x times the derivative of the x part, which is a -1. So y prime is -1 e to the negative x. So we're going to use these two things and plug into this to verify what they've given us is true. So 3 times y prime is negative e to the negative x plus 4 times y e to the negative x. So 3 times negative e to the negative x is negative 3e to the negative x. 4 times e to the negative x is just 4e to the negative x. And negative 3e to the negative x plus 4 to the e to the negative x, those are like terms, so that is just 1e to the negative x, and we have verified that those two things are equal. So this one was relatively simple. There wasn't a whole lot of work there. In this one, they're using some different symbols. Here they want us to verify that y squared minus 2 natural log of y equals x squared is a solution to dy over dx, the derivative of y with respect to x, and showing that that equals xy over y squared minus 1. So we're trying to verify that these two things are true. They use some different symbols here. Instead of y prime and y double prime, they're just using dy over dx. That really is the same thing as y prime. They're just using a different notation for that. Okay, it looks like we need to find dy over dx. We need to find the implicit differentiation of what they gave us. So that's what we're going to do first. So if I do that, 2y prime, every time I take the derivative of y, remember I'm going to put in a y prime, which is the same thing as dy over dx. It's okay to understand those two things are the same. And then we've got minus 2 times the derivative of the natural log of y. Well, that would be y prime over y, the derivative over the original. And then that equals 2x. We don't need a y prime over here because we were taking the derivative of an x term. Then we will need to get the y primes by themselves. So I'm going to distribute out a y prime. So that will give me a 2y minus 2 over y equals a 2x. Now understand, y prime is the same thing as dy over dx. Okay, there's nothing wrong with that. So that's the same thing as dy over dx times 2y minus 2 over y equals 2x. Well, to get the dy over dx alone, which is what we want to do here, right, I'm going to move this to the other side. If I divide by everything that's not dy over dx, I will have 2x over 2y minus 2 over y. Now, I think I want to get rid of the y on the bottom here, on the denominator of this 2 over y. So I think what I'm going to do is I'm going to multiply the bottom by y, and if I do that on the bottom, I have to do the same thing on the top to keep it equivalent. I can't change the value of what I've got. So I'm multiplying by y over y, or 1. So if I do that, I've got dy over dx equals 2xy on top. I'm going to distribute the y, so that would be 2y squared minus 2y over y is just 2. And then notice all three of these have 2's, so they cancel out. So I've got xy over y squared minus 1, and I believe that is what they wanted us to verify. So we finished. here they're dealing with some trig functions doing the same thing. They want us to verify that y equals 4 cosine 2x plus 6 sine 2x is a solution to y double prime plus 4y equals 0. So if we look at this notation here, they want us to find y double prime. Well, if we do that, first thing I have to do is find the first derivative, y prime. So y prime is going to be equal to the derivative of each of these separate. So the derivative of cosine is negative sine. So I'm going to have a negative sine 2x, and then I have to take the derivative of the angle part, which is 2, and I'm going to multiply that 2 by what was on the outside, or the number that was in front. So that'll be 2 times 4 is 8. For this term, the derivative of sine is cosine, so I'm going to have a plus cosine 2x, and then I have 6 times the derivative of this, which is 12. So there's the derivative of, or there's the y prime, first derivative. Y double prime, I'm going to take the derivatives separately again. So the derivative of sine is cosine. I still have the 2x. And then the derivative of 2x times negative 8 is negative 16. And the derivative of cosine is negative sine. I still have the 2x. The derivative of the angle part is 2, and 2 times 12 is 24. So there is y double prime. So now I'm going to take what I've got here, plug in here to see if in fact they do equal 0. Okay, so if this is y double prime, it says here that I need to take y double prime and add 4 times y, which is 4 cosine 2x plus 6 sine 2x, and show that that equals 0. Well, I'm going to distribute the 4 here. So I'm going to keep all of this, negative 16 cosine 2x minus 24 sine 2x plus 16 cosine 2x plus 24 sine 2x. All right, so negative 16 cosine 2x plus 16 cosine 2x cancels. Negative 24 sine 2x plus 24 sine 2x cancels, leaving me with 0 equals 0. I've verified that it's true.